Hello everybody, this is Ahmed Nyenga, a student in the Aga Khan University, and I'll be presenting the lesson on oxidation and reduction, as you can see on the PowerPoint. And this topic is actually found in Form 3 class, Tanzania. So in the first slide, as you can see on the left side, it shows some pipes which are highly corroded. So basically corrosion is also an example of oxidation-reduction reactions. So our coverage will be involving the meaning of oxidation and reduction in terms of oxygen, hydrogen, and electron transfer. As you can see, there are two pictures just below the coverage that are showing an iron chain that has been oxidized, that has been corroded by the action of oxygen to form rust, which is a brown coating found at the top of iron surface. So what actually happened when the iron was rusting? As you can see below, there's a reaction over here which shows iron reacting with oxygen to form iron 3 oxide or ferric oxide. So what is oxidation? We say oxidation is the addition of oxygen to a substance. So in this reaction, oxygen has been added to iron to form iron oxide. As you can see in the animation, we see that the oxygen molecules are added to iron 3 to form an iron 3 oxide. Iron has a valence of 3, which means it's the combining power of iron. So iron reacts with oxygen by donating, by giving its electrons, and oxygen receives the electrons in the formation of an ionic compound which is called iron 3 oxide, which is the rusting that occurs on the surface of an iron article. So what are the other examples of oxidation-reduction reaction? In this slide, there's a short video that shows another example of oxidation-reduction reaction, and this is the oxidation of copper to form copper oxide, which can be carried out in the laboratory. Because from where I stay, there is no laboratory nearby where we can actually be able to carry the reaction. This is just an animated video that shows how oxidation reaction can occur in the laboratory setting.
Oxidation and reduction, redox reaction. Aim: formation of copper oxide from copper. Requirement: china dish, copper powder, burner, tripod stand, and wire gauze. Activity: heat a china dish containing some amount of copper powder and observe what will happen. We can observe the surface of copper powder becoming coated with black copper oxide. Because oxygen is added from air to copper and copper oxide is formed, 2Cu plus O2 gives rise to 2CO. If hydrogen gas is passed over this heated material, copper oxide, CuO, the black coating on the surface turns brown due to reverse reaction and copper is obtained. CuO plus H2 gives rise to Cu plus H2O. If substance gains oxygen during a reaction, it is called oxidized. If substance loses oxygen during a reaction, it is called reduced. In this reaction, copper 2 oxide is losing oxygen and is being reduced. The hydrogen is gaining oxygen and is being oxidized. one reactant gets oxidized while the other gets reduced during reaction is called redox reaction.
Okay, so based on the video, now let's take a look on the reaction that is shown on the second slide. So the iron 3 that has been formed in the first slide, when the iron undergo rusting, can be converted back into iron through a reaction that is shown on this slide, and this is a chemical reduction reaction, which is also covered in the Form 3 chemistry in the reduction reactions or in the extractions of iron from its ore, which is iron oxide. So what really happens? We see that the iron oxide just be writing here, the iron oxide has changed into iron, Fe. So the change from iron oxide to iron, that means that oxygen has been removed. So the removal of oxygen from iron oxide is termed as reduction. So this is called reduction. Now let's look on the carbon. Carbon in the presentation here has been converted into carbon dioxide. So carbon has changed into carbon dioxide. Now what has been added from carbon to oxygen to carbon dioxide? As you can see, there is addition of oxygen into carbon to form carbon dioxide, and the addition of oxygen to carbon to form carbon dioxide, this is called oxidation, and this is reduction reaction, when iron oxide was actually converted to iron metal. A point to note is that always when reduction occurs, oxidation also takes place. They occur at the same time. Now let's check on the other example. Okay, so we saw that oxidation can be defined as the addition of oxygen to a substance, and reduction is the removal of oxygen to a substance. But in this regard, we do not have any oxygen removal or addition. But again, oxidation and reduction can be defined in other ways, and this is one of the other ways in which we discuss oxidation and reduction in terms of electron transfer. Electronic transfer, we learn about electronic transfer when we talk of bonding, chemical bonding in Form 2. Basically, the electrons are moved during a chemical reaction from an unstable element, so that the element attain stability or attain stable electronic configuration. So from the reaction, as you can see here, we have magnesium and sulfur. So magnesium, we remember the configuration of magnesium. When we talk of configuration, we are referring to the electronic arrangement of the electrons around the nucleus of an atom. So this is magnesium. Okay, so we have magnesium reacting with sulfur to form magnesium sulfide, which is also another ionic compound, but in this case there is no involvement of oxygen or hydrogen. So magnesium, being a metal, has donated electrons to sulfur, and itself being electron deficient, to form magnesium 2 ion, and sulfur has been converted to sulfide ion, which has gained 2 electrons. So how do we define oxidation and reduction in this case? We say oxidation is the process of electron loss. When an element loses electron to form its corresponding ion, then we say that element has been oxidized to its ion. When a nonmetal gains electrons, we say that is reduction. So let's see it in our board over here. So we have magnesium, which has been converted into magnesium ion. So before, magnesium had a configuration of 282, meaning that it had 12 electrons. But when it gave its 2 electron to sulfur, it turned out to have only 10 electrons. So because magnesium has lost its 2 electrons in forming the magnesium ion, which is alternatively termed as the process of electron loss, we say this is oxidation. So magnesium has been oxidized to magnesium ion. Now let's take a look on sulfur. So sulfur is just a nonmetal. Sulfur which has been converted into sulfur ion or sulfide ion. Sulfur has a configuration of 286, meaning that it has 16 electrons, and it has gained 2 electrons to form sulfide ion having 18 electrons, which matches the electronic configuration of a noble gas close to it, which is what? Which is argon. So a process of electron gain, we term it as reduction. So this is reduction. Now, to summarize our lesson, let's go back to the 4 definitions that we've seen so far. We say oxidation can just be the gaining or addition of oxygen, while reduction can just be the removal of oxygen. But also we saw that oxidation can be an increase in oxidation number. As you can see, the increase in oxidation number from 0 to +2 when we talk of oxidation number, we are referring to the numbers of electrons that an element can lose or gain in forming its ion. So magnesium is capable of losing 2 electrons to form magnesium ion, while sulfur is capable of gaining 2 electrons to form sulfide ion. So because magnesium has increased its oxidation state from 0 to +2, then we say magnesium has been oxidized, while sulfur has gained 2 electrons. Now we say sulfur has decreased its oxidation state from 0, which is the oxidation state of an element, a compound, a molecule, to -2, and that is termed as reduction. Now on the second on this definition, we see that oxidation can be defined as a loss of hydrogen from a compound, a covalent compound, or it can be defined as the addition of hydrogen from a covalent compound. Now let's look on one of the examples before closing our lesson. Okay, so we have copper oxide reacting with hydrogen. To form copper, metal, and water molecules. So copper oxide has been converted to copper. The conversion from copper oxide to copper involved the following changes. First of all, there is loss of oxygen atoms, which is termed as what? As reduction. In terms of oxidation state, we say that if you want to look for the oxidation state of an element within the compound, you then have to make it the subject, and based on the oxidation state of its combined element, you can then be able to find out the oxidation state of the particular element you want to know. So in this case over here, we say the oxidation state of a compound, the entire compound, is always equals to 0. So copper oxide has the oxidation state of 0, but oxidation, we say the combining power of oxidation is -2, which is its oxidation state. So if you need to find out the oxidation state of copper, you then have to do a mathematical calculation, a simple mathematical calculation, which requires you to make copper the subject in terms of oxidation state. So this is the expression. We say copper will be having the oxidation state of what? Of +2, because this -2, when it crosses the equal sign, it will turn out to be +2. And the oxidation state of copper as an element is always equals to 0. So we have oxidation state of copper being +2 in the copper oxide, and it changed to 0. So that one is termed as what? It's termed as reduction, because it's a decrease in oxidation state. Now in terms of hydrogen, and oxygen, we say oxygen has been removed from copper oxide to form copper, and hydrogen has been added to copper oxide to form water. So the process of adding hydrogen to a substance is termed as what? As reduction. And the process of adding oxygen to a substance is termed as oxidation. So the change